What moves you? What connects you? What powers you? Since the dawn of civilization, we have been looking for sources of energy to improve our life, our relationships, and ways to be entertained. We haven't always gotten it right, but there has been a lot of innovation along the way. Energy, at its most practical, comes in the form of electricity, and the most convenient way to deliver this energy is a battery. A battery is made up of 4 components: 2 electrodes, an anode and a cathode, a separator to prevent short-circuiting, and an electrolyte to move charges between the electrodes, converting chemical energy into electrical energy. While the earliest batteries date back to 200 BC, the first true battery, as we know it today, was the voltaic cell, created by Alessandro Volta in 1799. Over the next couple of centuries, we saw disruptive innovation with the first rechargeable battery invented in 1859, and then several incremental leaps, including nickel-cadmium, alkaline, and nickel metal hydride batteries commonly found in consumer electronics. The most noteworthy, of course, was the lithium-ion battery invented by John Goodenough in 1980. It was most noteworthy for its high energy density, which allowed for compact and powerful batteries in laptops and cell phones. But this advantage came with a few concerning flaws that still exist today. Other than thermal runaway, there are ecological and social concerns due to the disposal of toxic materials at the end of the cell's useful life and scarcity of required minerals like cobalt and how they're mined in the DRC. The Kitty Hawk Cora uses lithium-ion batteries for its futuristic air taxi service, but flight time is limited. Given current projections of energy density to weight of the craft, we could see these air taxis on a commercial scale by 2030. What about the future of battery technology? Organic redox flow batteries can handle large-scale energy storage that is increasingly required to balance the intermittency of wind and solar energy. And the materials used are much more sustainable than the standard redox flow battery that uses vanadium and toxic chemicals in their electrolyte. This technology is easily scalable, cost-effective, and much less degradable than the lithium-ion battery storage grids. Even with its lesser energy density, the reduced cost and degradation makes this an attractive solution for intermittent power grid energy storage. Aluminum-ion batteries are being developed by Brisbane-based Graphene Manufacturing Group with the promise of significantly reduced charge times, up to 60 times faster they claim, along with increased charge capacity, safer operation with little risk of overheating, and sustainable materials, making them easier to recycle. Plans are to bring the aluminum-ion coin cell to market late 2021, with automotive pouch cells planned to roll out in early 2024. Solid-state batteries are an older technology that is just becoming commercially viable. By using a solid electrolyte, charge density is increased, and the risk of explosion by dendrite growth penetrating the separator is eliminated. Renowned battery innovator John Goodenough has entered the fray with a glass electrolyte solid-state battery. Toyota is partnering with Panasonic in an attempt to become the first car maker to mass-produce solid-state battery-driven electric vehicles. But what if we didn't need a battery pack? What if the product and the battery were one and the same? At Tesla's 2020 Battery Day event, it was unveiled that they will be integrating the battery pack into the chassis of their vehicles, thereby strengthening the frame and utilizing the battery pack as an asset rather than an afterthought. Researchers are taking this a step further by making the battery weightless and invisible. These structural batteries have the potential to be a disruptive innovation, maybe the first since the rechargeable battery. An example of design thinking, structural batteries answer the question, why do we even need a battery pack? And the potential is incredible. By integrating the battery into the body, this virtually eliminates the weight of the battery. Just think what this can do to smartphone and laptop dimensions, electric vehicle range, and the aforementioned battery-powered flight capability. By making the battery weightless, we could see battery-powered flights sooner, with even more applications than just small air taxis. The energy that moves, connects, and powers us has seen remarkable advancement, thanks in large part to battery technology. Are we in the golden age of battery innovation? Demand for batteries will be 10 terawatt hours annually by 2040, up from 200 gigawatt hours today. This demand has created an opportunity for businesses to invest in battery technology and to push the limits of what batteries can provide for convenient energy delivery. 2018 had more than 7,000 patents filed on battery tech, up from just over 1,000 at the turn of the century. Will we be able to satisfy this demand? It's going to take a lot of innovation to get us there.